So, last class we have finished up to scale effect on bearing capacity. Earlier we have finished bearing capacity theories based on Terzaghi's, Meyerhoff's and as well as basics, and also we discussed scale effect on bearing capacity. Then effect of compressibility. These are different theories. Generally I allow students to bring the formula sheets examinations. Many charts formulas are there, particularly foundation designs. So, it will be difficult to memorize all. However, few like Terzaghi's bearing capacity theory, C N C gamma DFN Q 0.5 gamma B N gamma, it should be, you should at least remember, and this is a common formula generally used. So, effect of compressibility. So, what basic says, change in failure mode is due to, it is due to your soil compressibility. It is due to your soil compressibility, and basic 1973 proposed relationship considering your soil compressibility. So, ultimate bearing capacity QU is equal to CNC FCS FCD FCC shape factor plus depth factor, and he added one more factor, that is your compressibility factors. So, then QNQ FQS FQD FQC plus 0.5 gamma B F gamma S F gamma D F gamma C. Now, this is what he has given considering into your soil compressibility. Now, if I write it FCC FQC F gamma C, this is your soil compressibility factor, soil compressibility factor. So, how you are going to follow these steps? These steps are how you are going to calculate taking into consideration of soil compressibility. These are all your steps. Calculate your rigidity index I, calculate rigidity index I of soil at a depth B by 2, this is your depth, below the bottom of the foundation, below the bottom of foundation. So, rigidity index generally I or IR, index I for index, R for rigidity. IR is equal to G by C plus Q prime tan phi. G is your shear modulus of soil, and Q is your effective Q prime is your effective overburden pressure. Now, critical rigidity index. So, second one is your IRCR. IRCR is your critical rigidity index, which is equal to half exponential 3.3 minus 0.45 B by L cot 45 degree minus 5 by 2 So, step 3, they have given few conditions. If rigidity index I are greater than equal to critical rigidity index IR CR, then your FCC, FQC, F gamma C is equal to 1. If IR is less than rigidity index is less than critical rigidity index, then F gamma C is equal to F QC, which is equal to exponential minus 44 plus 0.6 B by L tan phi plus 3.07 sin phi into log 2 IR divided by 1 plus sin phi. So, this is what they have given. These are all kind of empirical in nature, doing very few tests, calculating few tests, and this relationship has come up. So, basic asked why there is a change in failure mode, that means from local shear to general shear failure, why it is happening. So, he has make it into because it is happening because of your compressibility, and effect of compressibility, instead of putting it like Terzaghi's, if general shear failure is there, condition is phi should be greater than equal to 36 degree, local shear failure phi is less than equal to 26 degree. Instead of giving that conditions, rather he added 3 factors FCC, FQC, F gamma C, that is your soil compressibility factors. And what are the steps? Calculate rigidity index IR based on your shear modulus of soil C and Q prime tan phi. Q prime is your effective overburden pressure, and this rigidity index IR has been calculated at B by 2 depth below your bottom of foundations. Then second is your IRCR, that means critical rigidity index, he has given expressions, and compare with your critical rigidity index with your rigidity index, and if rigidity index is greater than critical rigidity index, then FCC, FQC and F gamma C is equal to 1. If rigidity index is less than your critical rigidity index, then find it out F gamma C and FQC, and then for FCC, for phi is equal to 0, he has proposed FCC is equal to 0.32 plus 0.12 B by L plus 0.60 log IR. For phi greater than 0, FCC is equal to FQC minus 1 minus FQC divided by NQ tan phi. This is what he has given. Take an example. So, given data, one example, given data, what are your given data? Given data is your B is equal to 0.6 meter, L is equal to 1.2 meter, foundation size, depth of foundation is 0.6 meter, phi is equal to 25 degree, C is equal to 48 kilonewton per meter square, gamma is equal to 18 kilonewton per meter cube, then E value modulus of elasticity has been given 620 kilonewton per meter square, and Poisson's ratio mu is equal to 0.3. It has been given these values with a size 0.6 and 1.2, depth of a foundation is 0.6, phi is given, C is given, gamma is given, E is equal to given, mu is equal to given. Then find it out rigidity index IR, which is equal to G by C plus Q prime tan phi. You can calculate G, where G is equal to E by 1 plus 2 mu, and from there also you can calculate Q prime, effective overburden, which is equal to gamma depth of the foundation plus B by 2. If you look at here, it has been considered up to a depth equal to B by 2, width of the foundation by your 2. So, from there you find it out, it should be 18 into 0.6 plus 0.6 by 2, which is equal to 162 kilonewton per meter square, and now IR you can calculate, which is equal to 4.29. Then you calculate this value, this is your rigidity index, critical rigidity index you have to compare. So, IR CR, critical rigidity index, you calculate, this value is coming about to be 62.46. So, now what will happen from this, what you are getting, IR rigidity index, IR is less than IR CR. Now, once it is less than, then you calculate FRC, which is equal to FQC based on your suggestions or the empirical relations has been given. From there it is coming 0.347. Then you calculate FCC, which is equal to also, because it is phi is greater than 0, phi is 25 degree, FCC is coming about to be 0.216. Then ultimate bearing capacity you can calculate, considering shape factor as well as depth factor, compressibility factor, all you consider it. Then this shape and depth factor will be as usual for your basics theory, same it will come there, only here only compressibility factor will come into picture. So, then so it is coming about to be, ultimate bearing capacity is coming about to be 474 kilonewton per meter square, kilonewton per meter square. So, this is what about your effect of compressibility. Now, come to the next, what are the bearing capacity recommended by IS code, Bureau of Indian Standard. Generally people say IS, generally we can write it BIS. BIS is your Bureau of Indian Standards. What is its recommendation for your bearing capacity? So, Bureau of Indian Standard, they have given QNU, they have not given QU. QNU is your net ultimate bearing capacity, which is equal to CNC SC DC IC plus Q into NQ minus 1 SQ DQ IQ plus 0.5 gamma B N gamma S gamma D gamma I gamma W prime. So, this particularly this is your Bureau of Indian Standard, the number you can note it IS 6403 1981, it has been revised. So, it will be IS 6403, you can download from your library if it is accessible. So, what they say in this term, so QNU they have given a net ultimate bearing capacity, and they also suggested NC, NQ and N gamma, it will be as per this is your bearing capacity factors as suggested by basic. Bearing capacity factors are suggested by basics. There are three cases, one is your Terzaghi, other is your Mehrhoff, third one is your basics considering safe depth factors. From there you take it, then W is your water table effect. W prime is nothing but is your factor takes into account effect of water table, So, if W prime is equal to 1, what does it mean? So, water table is below a depth or at the base of foundations or below at a depth which is equal to dF plus B, below at a depth which is equal to dF plus B. So, then they have given the water table corrections, varying from 0 to 0.5. If it is fully submerged case, then it will be 0.5, that means depth of the water table is at, I can say depth of the water table at the ground surface, that means dW prime is at the surface at the 0, then W prime is equal to 0.5, which also we have earlier discussed why it will be 0.5. In this term, gamma bulk unit weight will be converted to submerged unit weight. Once it is a submerged unit weight, half of the part will be reduced. So, automatically the reduction factor will be 0.5. So, it will be linearly interpolated in between 0 to 1 and W prime can be interpolated between 0 to 1 if water table is located 0 dW prime less than B. This is what I have already said, water table corrections earlier. So, they have given different factors for different cases SC, SQ, S gamma, DC, DQ, D gamma, IC and I gamma. So, these are the cases they have given. So, shape, depth and inclination factors, shape, depth and inclination factors. So, if I start with this Bureau of Indian Standard, they have given this is your factor and these are all your values. You can download this code. So, they have given SC, SQ, S gamma, then DC, then DQ is equal to D gamma, IC is equal to IQ, then I gamma. They have given the value. So, particularly they have given 1 plus 0.2 B by L for rectangular Bureau of Indian Standards. So, then 1.3 it will be for square and circular foundations. Similarly, SQ will be 1 plus 0.2 B by L, it will be for rectangular, then 1.2 for square and circular. Similarly, S gamma Bureau of Indian Standard has been proposed 1 minus 0.4 B by L, then it will be for your rectangular, then 0.8 for square and 0.6 for circular. DC is equal to 1 plus 0.2 dF by B tan 45 degree plus 5 by 2. Then dq is equal to d gamma, it would be 1 plus 0.1 dF by B tan 45 degree plus 5 by 2 for phi greater than 10 degree and 1 for phi less than 10 degree. Then for IC is equal to IQ, inclination factor for C and Q, it will be 1 minus alpha by 90 whole square and I gamma will be 1 minus alpha by phi whole square. Why I have written this code? You could have downloaded it from Bureau of Indian Standard site or maybe from your college library, but many colleges, private institutions, they may not have these codes. So, that is why these values I have written. So, you can note it down and prepare a chart for your examinations. So, sometimes it has been asked design based on your Bureau of Indian Standards. Here in this case alpha is in degree. This is particularly your cohesionless soils. For cohesive soils, purely cohesive soils, Bureau of Indian Standard QNU net ultimate bearing capacity is CU, NC, SC, DC, IC. So, NC is your 5.14 and SC, DC, IC is your shape, depth and inclination factor as it is given. Now, come to next part, that is your bearing capacity of soil based on your standard penetration values. Bearing capacity of soil based on SPT values. Earlier in soft soil investigations, standard penetration test I have explained. In standard penetration test, what you are supposed to get? You are supposed to get N values for last 30 centimeter of your penetrations. From N value, what you are supposed to get it? There are correlations. From N value you are supposed to get your phi. Once you get the value of phi, from there you are supposed to get your bearing capacities. So, Peck, particularly this has been given by Peck, Hansen and Turnbull 1974. They have given it, you can get it from the book. This chart you can take it out for your examinations. This is your angle of shearing resistance phi. It varies between 28 degree to 44 degree. Then this is your bearing capacity factor NQ and N gamma. Then here they have made it this is your very loose, this is your medium, this is your dense, this is very dense, and here is your N values, this side also N values. They have given these values starting from 0 to up to N is equal to 60. So, here this kind of graphs they have given. This is the variation of your N. Zero 20, this value is your N gamma, this is your NQ. Now, if you look at here, once you have a penetration value N, this N value is there, from N value is there, from N value you can calculate your phi. Once you know the phi, from there this has been extended. Suppose phi is varying from 28 degree to 44 degree, you extend it, where it cut it, from there you can find it out NC, NQ, NQ and N gamma, NQ and N gamma. This is what they have given to find it out, NQ and N gamma, and this chart has been widely used. So, two correlations they have given, one is your phi is equal to 25 degree plus 0.15 dr fines greater than 5%, then phi is equal to 35 degree plus 1.15 dr. So, fines less than 5%. Dr is your degree of compactions or relative density. Relative density based on your N value, you can calculate whether it is a loose state, medium state, what is the relative density. From there also you can find it out the value of your phi's. So, this is based on your SPT. standard penetration values. So, next is your based on your cone penetration values, and some of the cases has been given by some formula given by Teng. Then next will be bearing capacity of footings, particularly on layered soils. Right now whatever we have discussed, that is a single soil. It may be possible, it is always happen in the field, every 2 meter interval or every 1.5 meter interval subsoil profile is changing. It is not necessarily 1.5 to 2, it may be 0 to 5 meter and 5 to 10 meter another subsoil profile. If there is a layered soil, how do you calculate bearing capacity? That part I will discuss in the next class. Once it is over, I will go for your settlement calculations, immediate as well as consolidation settlement, particularly in sand as well as in clays. Once it is over, then we will go for foundation design. Thank you.